Hello. So I want to do this question here. We have this situation where this is the cost function, and what we're trying to do is minimize the average cost. So first we write down what the average cost is. So if we take the number of items we make, C of x, and if I divide by x, that's the average cost to make each item. And using our formula, so this is what we're calling this C hat, right, for average cost, we find that we get, well, if I divide each of those terms by x, I get x squared over 2 plus 2x minus 3 plus this 35 divided by x. Okay, so we want to find the derivative so that we can find out where we have our minimums, our maximums cost. And when we differentiate that, we see we get x plus 2, and then over here we get minus 35 x squared. Okay, so we'd like to now, this is use a graphic calculator to find out where this is 0, because see, this would be a difficult thing to solve, by hand. So it's good to be able to use this technology. So I'll do that right here. Okay, so here's our graph right here. You can see the using this little computer program here, my Mac, I guess. And here we see the derivative right here. Okay, so it's this x plus 2 minus 35 over x squared. Okay, and here's the graph. Now that's the derivative of the function we're trying to minimize. So it looks like if I zero in there, it looks like it's happening right about there. So the x value where that's happening is, looks like a little bit more, almost 3, right? Slightly less than 3. And if we wanted to get it very accurate, we could. The next part of the exercise is to make sure it makes sense. So what I'm going to do is I'm going to also graph on this axis the graph of the function. This here is a part of the graph of the function, the average cost. And you can see that the average cost is minimized at that point. And it looks like the average cost would be about, let's see, if this is 15, what are these? 1, 2, 3, these are, okay, so these are 1, so it'd be 15, 16, 17, 18, about 19 would be the average cost of each item if we were to produce, a 2.75, and we could very accurately approximate that if we wanted to. So that's a nice utilization of this calculus when dealing with a business application. So thank you. Hope you enjoyed it.